For a uniform distribution, we're going to use a notation. The notation is going to be, as you guys can see, let me highlight my notation here. That little X, the big X, basically tells me it's a uniform distribution. And you guys see the wiggly thing. And then I use the letter U for uniform distribution. The uniform, and then I have letters A and B inside parentheses. In general, those are going to be numbers. A and B are going to be numbers. A is the smallest number of my data. So I'm going to have some data. I'm going to have a list of numbers. A is the smallest number of my data. And B is the highest value of my data. I even wrote over here where A is the lowest value of X and B is the highest value of X. Now, the formulas for the theoretical mean and standard deviation are going to be a little bit different than what we are used to. So theoretical mean, so I notice how I use the Greek letter mu. I remembered I told you guys before, for the mean, the regular mean, we basically is the average, right? We add them all divided by how many we have. There's even, I even mentioned a few units behind, I talk about the sample mean. We add them all and divide it by one more than how many we have. Okay, what did you just say, Mr. Leon? So imagine I have a list right here. Imagine I have this list right here. There's 55 smiling times. So the table below represents 55 smiling times in seconds of an 8-week-old baby. For me to find the mean or the just regular mean, just for me to find the mean, I add them all. So 10.4 plus 19.6 plus 18.8, add them all divided by 55, and that's the mean. The sample mean, there's a difference. The sample mean, I will add all of these and divide it by 56, not 55, 56. It's always one more than how many you have. When we have a sample mean, it's a little bit different than the mean. But for our union distribution, we're going to do something different. We're going to get it a little bit faster. And I'm going to say my formula for my mean, it's going to be pretty close to our sample mean, but it will be a little bit different. My formula will be A plus B. Remember, A is the smallest number in my list. B is the biggest number in my list. So I'm going to add the smallest plus the biggest, and I'll divide this by 2. And that will give me what I call uniform distribution mean. Okay. Now, this little circle thing with a little stick at the side, remember we call that sigma? And we said that's the symbol for standard deviation. Now, I remember I gave you guys a way of how to find the standard deviation. Remember, we will find the distance between each number and the mean. We will square it, and then we will get the average of the new list. That's a few units back. But for our uniform distribution, what I'm going to do, for me to find the standard deviation, I'm gonna go B minus A. And remember, B is the biggest number, A is the smallest number. So I'm gonna go B minus A. I'm gonna square the result. So square it. I'm gonna divide it by 12. It's always 12. It doesn't matter how many numbers there are. So B minus A all squared divided by 12. And whatever I get, I'm just gonna get the square root of it. Okay, so let's take a look at here. The table below represents 55 smiling times in seconds of an 8-week-old baby. So we saw 55 8-week-old babies, and we saw how long they were smiling. Now, the sample mean is 11.65, and the standard deviation is 6.08. Fine, we can find that out. However, Let's find the theoretical mean and the standard deviation of our uniform distribution. Our numbers, my numbers are going to be a little bit different, but pretty close to those numbers that you see there. What I'm going to do for my mean, I have to go A plus B. Okay. First of all, let me find which one's the smallest number and which one's the biggest number. I see here, see my smallest number. I think it's 0.7. Do I see anything smaller than that? No. Now, my biggest number, I see 22.8. There's another 22.8. Okay. Now, what I'm going to be doing here, because I'm not going to be using decimals, what I'm going to be doing here, I'm going to say this uniform distribution is in between the numbers 0 and 23. I have to make sure I include all my numbers, right? 0.7 was the smallest, so I went down to 0. I rounded down. And then 22.8 was my biggest number. I rounded up. So I'm going to say my uniform distribution of 0 to 23. So that gives me my smallest and my biggest number, 0 and 23. So for my mean, my theoretical mean, let me go 0 plus 23 divided by 2. Okay, 0 plus 23 is 23 divided by 2 is 11.5. My sample mean was 11.65. My theoretical mean is 11.5. Pretty close to each other. Not too bad. Now my standard deviation, my sample standard deviation is 6.08. Now for my standard deviation using this uniform distribution, I'm gonna go 23 minus 0, which is 23. I square my answer, which gives me 529. I divide this by 12, which gives me 44.08 and a bunch of threes. I get the square root of that, and it gives me 6.639528.095. Okay, so let me round it to 2 decimal places. So I'm going to call this 6.64. That's it. So it's a little bit easier. Our theoretical mean and standard deviation or uniform distribution, make sure you guys use those formulas. Now for two values, A and B, okay, let's take a look at this. I can give you guys these figures right here, and I can ask you for a probability. And I'm going to say, well, the probability that X is in between A and B, it's equal to B minus A over D minus C. Keep in mind A and B are in between C and D. So I'm also going to use these formulas for uniform distribution. take a look at an example. What is the probability randomly chosen 8-week-old baby smiles between 2 and 18 seconds? Okay, so I'm just gonna say, I'm asking, what's the probability that X is in between 2 and 18? Because remember, it says, what's the probability that randomly chosen 8-week-old baby smiles between 2 and 18 seconds? So what's the probability between 2 and 18? What I'm going to be doing, I figure this as a rectangle. Remember how I went from 0 to 23? I want that whole rectangle to be area of 1. So I'm going to say the height of this is 1 over 23. And I'm looking for between 2 and 18. You're like, oh, this is pretty much like we saw last homework with our continuous probability distribution. Pretty much. What I'm going to be doing, I'm going to say, okay, let me change this to blue. So I'm looking at my work. I'm looking at this new rectangle. I'm going to say 16, right? Because 18 minus 2, I subtracted those two values. 16 times 1 over 23. It gives me 16 over 23. Okay, well, I got to see that as a decimal. 16 divided by 23. I'm going to round this to 2 decimal places. Because right now I have 0.695 and some more numbers, but I'm going to round it to 2 decimal places. I know the 5 pushes the 9 over, but the 9 is at the limit, so the 9 ends up pushing the 6 over. So my answer will be 0.70. I answered this as a 2 decimal place. Okay, now let's take a look at over here too. 90% of the smiling times fall below the 90th percentile, which we're going to call K. So X is less than K is equal to 0.90. Okay, well, let's find the K. What's the percentile? What's the 90% percentile of this thing? So all I know right now is that the probability that X is less than K, I don't know what K is. That's what we're going to figure out. X is less than K, it tells me is 0.90. So I know basically that if I do this as a rectangle, I can go the base times the height. It's equal to 0.90. Now, the base, I'm going to say it's K minus 0. Again, I don't know what K is. The base is K minus 0. The height, we said the height of my rectangle was 1 over 23. And this is equal to 0.9. Okay. Let's solve for K. What I'm going to be doing now, let me multiply both sides by 23. Because that way, this cancels out. I have K minus 0. My parentheses that I have left is K minus 0. But is it okay if I just write K? Because K minus 0 is just K, right? Now, on the other side, 0.90 times 23, it gives me 20.7. So 20.7 is the 90th percentile. What does 90th percentile mean, Mr. Leonzo? The 90% of our population is below 20.7. I could have asked you, Give me the 30th percentile. Give me the 50th percentile. Percentile is how much percent are below such number. Okay, there you go.